Welcome. This is part 1. Actually, a very class I don't have to tell because you can see. Anyways, habit. Part 1, lecture, I think lecture 12. 99% is lecture 12. Okay, I didn't see earlier, most probably 12. Now, why I am writing? Because sometimes I have to explain what I am doing. Today, make a note. I am covering a critical example for resolution. See here, we are not finding resultant, this is not a problem. Purpose is only to find components. A critical example you can write for resolution along x-axis and y-y when x-axis is horizontal, y-y is vertical. Okay, now, next class what I will do is, today I used the green color, x-axis like this, y-y like this, just to understand. In the question only given, x-axis like this, y-y like this. Next class what I will do is, I will take one of the x-axis, y-y inclined, this way. Why you require, I will tell you later, next time. See, sometime in the friction chapter, inclined plane problems, or in strength of materials, there is a chapter called principal compound stresses, where principal stresses, oblique plane comes there, you have to resolve the forces. One, see, there will be inclined plane will be there, some plane will be there here. See, in the strength of materials, you will get a case, okay, don't that color, black only will write. See, there is an element will be given. Then you have to find expression for normal stress, shear stress on any inclined plane. Then you require resolution once along the plane, once perpendicular to the plane. And also in case of arches, see, in case of arches, sometimes you require radial shear and normal thrust. There, even if the force is vertical and horizontal, you have to get the component once radially, once tangentially. So purpose is to make everything clear. This is next class, not now. Today's class what I will do is, today's class is general case. But see, someone will tell, what is all this happening? Why this much? No. I am ensuring that those who go through this class thoroughly in their entire life, of course, provided they correctly understand, practice, and once in a while keep in touch. In their entire life, there are no difficulty for resolution. Today's class for x-axis, y-y, when x-axis is horizontal, y-y vertical. Tomorrow, next class is tilted. X-axis, y-y are inclined, but both are mutually perpendicular. Okay, start. Now, first, master question for resolution of a force. Question. Find components of all the forces along x-axis and y-y. Okay. System is given in the question. Some dimensions given. I will tell you later why dimensions given. Okay, now, this sketch don't see here. This is a sketch I reserved later only if required. See, this is if required. I will write later. If required entry. Our purpose today is to get the components. But suppose this question is find resultant for the given force system. Then you have to take moment of the forces all. In that case, whatever components you got, you have to enter all the components neatly. So, but I am entering the component and stopping the question. Later when I go to resultant for coplanar force system, I will continue. Okay, start. First I will do one thing, okay, 1 minute. Before starting, make a note. Before I start, I will give you some do's and do nots. I will not write because these are all told earlier. Therefore, I will dictate one by one. See, 1 point number. You should write those who are serious. Here I will not write. Only in the notes I will write this one. Point number 1. Always consider the angle with nearest x-axis. That is, never consider angle more than 90 degrees. See, there is an angle here given 130 degrees. If you consider this, what happens, you will be knowing later. Chance of making mistake. So therefore, point number 1, always consider the angle with the nearest x-axis. Actually, you can consider the angle with x-axis or y-y, anything. But if you consider with x-axis, x component cos, y component sin. If you consider with y-y, y component cos, x component sin. This all I told last time. But now, then I told you, in future, in my class, I will stick to one concept. I will tell, consider the angle with the nearest x-axis. Somebody may question me, why not y-y? I will tell, keep quiet. Did not hear what I told last time? No, I did not see. Then why you came to this class? See, I will talk that way only. Very clearly I told last time, you can take anything either with x-axis or y-y. Then I told, to avoid confusion or to make easy for you, we will stick to a concept. Does not mean that I cannot take angle with y-y. I can take angle with any axis. For me, there is no confusion. But your confusion to be minimized. So, point number 1, consider the angle with the nearest x-axis, that is always less than 90 degrees. 1. Second concept, second point. Then, without seeing here and there, x component is cos, y component is sin. Next, third concept. If the force is this way, components are, see, like this. So that, see, this given force should go in between. This all I told earlier. If you mark this way and this way, then only this force will go this way. So therefore, if you want, in using pencil, mark it. But actually not required. See, force going this way, somebody will tell x is this way, y is this way, crystal clear. Or, third point, if the force is this way, then components are this way. Whereas, if the force is this way, components are like this. If the force is this way, components are like this and like this. This all I told earlier. Okay, make a note. That concept also clear. Second point. Next point. Very carefully get the angles. Angle can be directly given. Thank you. If directly not given, you should find the angle. How? We will explain. So, or you once again go back to point number 1. Always consider the angle with the force makes with the nearest horizontal. That is less than, not horizontal, nearest x-axis. Actually here horizontal only. Less than 90. For that one, I am uploading a class in another series. I told you. Do's and do nots, common mistake committed by people. There I will ask a question first. Then I will clarify it. Okay, start. I think furthermore is not required. Nothing more is there. Okay, start. Now, first, right here. Consider, I will start from easiest forces. Easiest force to consider will be, see, 75 Newton. Why? Directly force passing here, 65 degree given. Therefore, see, consider, I will take 75 first. 75 Newton force. I have seen that all forces are different magnitude. Suppose this is 75, this is also 75. You number it, 1, 2, 3, 4 like that. You tell 75 acting at D. Anyway, you can make out. Okay. Like sometimes name. If two persons have identical name, initial will be there. If that also is same, something else will be there. Okay, 75 Newton. See here. See correctly through which point it is acting. It is acting to the point D. So mark the point D here. D. This is D. 75 Newton force is coming like this. I am not using scale actually. See, it is coming like this. See, when you resolve, there is no rule that force should be outgoing or incoming. Direction important. This is 75 Newton. Therefore, without seeing here and there, you can tell 1 minute vertically down, see, and horizontally left. Okay, this is clear. Now, mark the angle with the nearest horizontal. See, nearest x-axis. This is your x-axis. X-axis. This angle. Oh, directly given 65 degree. You write thanks. You can write thanks there. Okay. Equal to, resolve it here. Through the point D, see, one component this way, it's actually, you mark this anywhere. Finally, these two will come to this point. Remember, where you mark pencil, finally comes here. So this point has got a vertically downward component and horizontally left component. Or, okay, I will tell to the horizontal vertical because today x-axis is horizontal, y is vertical, and we took the angle with the nearest horizontal. So without seeing here and there, 75 cos 65, 75 sin 65. Calculate the answer, get the answer. Now 1 minute. I will calculate clearly. By chance, see, this is not a question for finding resultant. Therefore, in case any calculation mistake is there, no problem. Because we are not using this value, don't make an issue. I'll be careful, no doubt, but still 75, whatever, check it here, cos 60 equal to 0.5. Why? I am confirming for it is in the degree mode. Suppose in radian mode or gradient mode, problem. Okay. 75 into cos 65 is 31.696. This is 39.696 Newton. This will be 75 into sin 65. If wrong also no problem. 67.973. See, I told you, calculation mistake, spelling mistake, occasional maybe grammar mistake, that are not technical. Don't make issue. Okay, now over. So 75 over. Now do one thing. Lastly, not now, I will do it somewhere outside, you make a note. Won't see, this is lastly. If required for continuation, then at the point D, this is the point D, see here, one vertical downward force of 67.973 Newton, one force this way of 39.696 Newton. If required, not now, lastly. You write here. Lastly, I write one thing. Just a neat answer I am writing. So therefore, now I round off, 75 is over. Go back. Start next. Next force, I will take 40 Newton. Consider that, hope there is no, only 140 is there, yes. Other different, 100, okay. Consider 40 Newton force. 40 Newton force, see, this one. It is again passing to the point D, mark here, D. The force is coming this way. How much force? 40 Newton. Therefore, those who want to use a pencil mark and write here, see, through this point, finally you have to write, even if your pencil mark is here, it is finally here only, and like this. Okay. Now, mark the angle with the nearest x-axis, means this side x-axis, this side. This angle we require. See, now, this is 65 degrees. This is 50 degrees. 65 plus 50, these all I am explaining, those who are right, depending on the class only, that is not taking the notes, you should write all this one, because in the class I can't write, but notes not that way. I am writing everything. Let that angle be alpha, I will show the calculation. Here not required, see. 65 degrees, 50 degrees, total. See, you don't know. When summation, etc., multiplication comes, when calculator is not used, it always comes in a mother tongue. My mother tongue is Kannada. See, just for fun. If suppose you are not in Indian, don't worry. 65 plus 55. I am not used to add and multiply in English language. 4 into 8, I cannot write 4 into, see, 4 ಎಂಟ್ಲಿ 32 ಇಲ್ಲಿ 65 50 60 11 115. See, because mother tongue language, how I learned mathematics first time in the life, that is in second standard, I think, most probably, when they started telling 1, 2, 3, 4, so that will remain. So how much I told? 65, 115 degrees, then this angle will be, I can calculate, I don't want a mistake. See, this total is 180, what to do? From 180, subtract 65, subtract 50, or subtract, once again comes 65 degrees. Okay, no, change it. Not 50 degrees. You make it Any other 60 degrees there? No other 60 degrees there. No. Make it 60 degrees. I do not want same answer. 60 degrees. Change the question. Question changed. Then 65 plus 60. Change the question. 65 plus 60 is, because I do not want same answer once again. 65 plus 60, 125 degrees. So 180 minus 125 is 55 degrees. This angle calculated 55 degrees. Make a note, calculated value. Do not consider this angle. Do not take 65 plus 60. That is more than 90. What happens? I will let you know later. Don't worry. Now, we consider the force here. This is the point D. Our angle is with nearest horizontal. So without hesitation, equal to x component like this. This is the same point D to the point D. X component this way of 40 into angle 55 cos 55. Y component is down of 40 into sin 55 equal to. I will write the answer now. 40 into cos 55. If by chance some calculator button problem, if I write wrong answer, don't make an issue. 22.943 Newton. One thing sure, this should be slightly higher. Y means, I know little mathematical concept also. Sin 55. 32 point, this will tell me correct answer. 32.766 Newton. Over. This is the resolution. Now, 40 Newton force is over. I will cover this one. This also over. Lastly, see, when I enter through the point D, this is a D point, I will apply one force like this force. How much? 22.943 Newton. And one force this way of, where it is, any problem is, no problem. 32 point, space problem is not there. 32.766 Newton. One force comes here, it comes here, no problem. Okay. Now, this force also over. Next force I will take is 50 Newton force. Why? Easy to calculate. Direct angle given. See? Direct angle. Okay, I'll remove this one now. Directly given. So, first I will finish all the forces which are directly given. First. Next. Consider 50 Newton force. See, it is passing to the point C. To the point C. The force is like this. 50 Newton. Now, I want the angle with the nearest x-axis. Oh, I want this side angle. See, I want this angle. How to get it? See here. When this is 10 degrees, you can use 10 degree. If you use 10 degree, vertical becomes cos, horizontal becomes sin. I told don't do it. Why? If they give 10 degree, this angle is 80 degrees. I will not explain why 80 degrees. If you want, remember calculated value. What calculation? High school, primary school student will tell the answer. Now, components are through the point C, see, like this and like this. So, this will be equal to one component like this, one component like this through the point C, 50 into cos 80. This is 50 into, 1 minute now. I made the board a little bigger. I hope, so think that it is not out of camera, because today I made the board a little bigger. Zoomed more. Visible. Okay. Otherwise, full re-record once again. Okay, no problem. Because usually I keep little more, bigger means what? I zoomed little. Okay. So that everything is clear. 50 into sin 80 is 49.240. 49.240 Newton. Answer. Other one is 50 into cos 80. 8.682 Newton. 8.682 Newton. I'll check the answer now. You don't bother. 10 into cos 80. 10 into cos 80. What is the some problem here? 10 into cos 80. It is giving 1.73. Something wrong. Or not 10, sorry. 50 into cos 80. Okay. 8.862. Okay, 15 call it. Correct. Or I can tell 50 into sine 10 also will do. You don't worry about it. Okay. And that's for me only. Now this 50 Newton force also is over. Therefore, later, see, this is the point D. This is no space right here, D. Okay. Later, through the point C, not now, later, if you want, you can write a right side force of 8.682 Newton. Hope it is within the camera, and a vertically upward force of 49.240 Newton. Hope it is not outside the camera, because not, yes, I have to tilt the camera slightly. Yes, correct. See, it is slightly out of camera. Okay, see, luckily I noticed it. Okay, now okay. It has gone slightly out of camera. Okay, now I noticed it, luckily. Now I will be careful. Okay, this also over. Okay, start. Next force. See, today, see, I have not a prepared solution. I am solving in front of you only. Okay, I'll remove this one now. It's also over. You write all the statement and solve. Now, next, see. Consider which one? 60 last I want. This over. Okay, I will consider first 100 anything. Okay, I will consider this one. 80 Newton force. This one last I will take. Consider, I should not go beyond this line. Okay. Consider which one? 80 Newton force. Newton force passing to the point A. See, this one, 80 Newton. Now do one thing. The force is here. See, it is passing to the point A. The force is like this. How much force? 80 Newton. Okay. See why I am asking how much force? Here only it is there. 80 Newton. Now, I told you we want the angle with nearest x. This angle we want. See, this angle we want. Put a question mark there. Or leave it. Let that angle, put a question mark, you write here, let that angle be theta. Okay, let it be theta. Okay, not theta, 1 minute. Theta I can take, yes, let it be theta. That theta we want. It is not given in the question, but no problem. Some data, 1 minute, before that one later, see when you resolve, one component like this, one component like this, already known for you. Okay, now do one thing. To get theta, see here, the 80 Newton force is given like this. This is how they told 80 Newton force. Big sketch. Up to the point A. They are given something here, see. See now, we want this angle, see. 80 Newton force, what angle it makes with xx means this is xx. This is our angle theta. If that is theta, this also theta only. Why means I cannot answer the question. See, if someone will ask, sir, if that is theta, why this also theta, sir? What to do? You better not study structural engineering, go for some other field. That's the answer I should give. These are parallels. Now, they told this is 3 units. This is 4.5 out of scale. This should be smaller. Okay, no problem. Actually, 4.5 out of scale. Somebody will ask, 3 what? We don't know. See, some millimeters are here. It can be 3 millimeter, 4.5 millimeter. Or it can be 3 kilometer, 4.5 kilometer also. See, there is no limit. As we extend this one for any length, this also will increase. So, actually, unit is not required because when you calculate theta, linear dimensions are used, but it is independent of linear unit. Therefore, see here, this is 3, this is 4.5. Therefore, your tan, I calculate here now, your tan theta, see, tan theta equal to 3 divided by 4.5. 4.5. Therefore, your theta equal to calculate. Again, if someone will ask, sir, why 3 by 4.5 means no answer from me. Sorry, no answer. Tan inverse answer. 33.69 degrees. 33.69 degrees. Go back and enter. See, theta equal to 33.69 degrees. Remember, calculated answer. Okay, now, okay, over. Therefore, this will be equal to a horizontal through the point a component like this and a component like this. This is 80 cos 33.69. This is 80 sin 33.69 equal to 80 into cos 33.69 equal to 66.564. 66.564 Newton. Other one is 80 into sine 33.69 is 44.376 Newton. Correct answer? Yes, 44.376 Newton. Therefore, later, if you want, through the point A, you mark one force this way. How much? 66.564 Newton is the point A, and another force like this of, any space problem? No. 44.376 Newton. Okay. That also entered. Now, this force also over. Now you are left with, this is last I am doing. Okay, come to 100 Newton force. Now, another is 90. Now there is a problem here. For 90, no, make a note here, no data given. But for 100 Newton force, see, they told AB equal to, DC equal to 45. And then they told DE equal to 30. So you can get this distance. And also they told BC equal to 22. BF equal to 12. You can get this distance. So using these two distances, you can find this angle. But it is told 90 is depending on 100. See, they told 90 is perpendicular to 100. So make a note, unless you first get the angle for 100, you cannot get the angle for 90. Therefore, make a note here. Next, 100 Newton and 90 Newton, right here. Make a note here. Data required for finding angle is given for 100 Newton. 90 Newton just told it is perpendicular to this one. Therefore, unless you locate 100, unless you get the angle for 100 Newton, you cannot get the angle for 90 Newton. So, angle for 90 Newton depends on what is the angle for 100 Newton. Therefore, compulsorily, first, compulsorily, first 100 Newton. See, one is, this 90 is depending on 100, direction of 100. Okay. Now, this I can remove, yes. Now, see, I remove this also. See here. Mark the point E. First to do one thing, consider 100 Newton force. Now, where? See, there is a rule. This force of 100 Newton is, see, it passes through E and passes through F. Point of application is not given. Make a note here. In engineering mechanics, when you are not considering deformation, remember, very important, when deformation is not considered, by law of transmissibility of forces, this 100 Newton force can either be marked at E or can be marked at F. Completely your choice, no problem. You can consider 100 Newton force either at E or at F. Right here, you should write all these things by principle of transmissibility of force I told earlier. So you can consider 100 Newton force either at E or F, or you can consider it at any point along its line of action. So 100 force, consider 100 Newton at your choice. Okay, I will consider at E. At E. Now see here. This is the point E. This is the point E. 100 Newton force is here. So now this is the point E. Any point you can take. Later when I go for, see now right now leave it. Later when I go to coplanar force system, I will give identical question, simple question, where once I will resolve at E, once I will resolve at F, moments will change, but still answer will come same. I will show you at that time. Right now write, or right now you write there, we can believe him, you can believe me. Okay, now we want this angle with the XX. Why? Nearest. Once again, let it be theta. This is not that theta gone. This is a new theta, theta for this one. Okay, theta. How to get it theta? See now, this theta is to be calculated. To get theta, see here, E point is here, F point is here. See? Okay, now this is our theta. So you require this length and this length. See correctly. Now see, you are not studying primary school or high school or PUC, etc., SSLC like that. In structure engineering. So what I dictate you write. In the notes I will write. In the question they told DC, see, you should write, it is given DC equal to 45 millimeter. Whereas DE equal to 30 millimeter. Means, see here, from D to C is 45 millimeter, D to E is 30 millimeter. Therefore, EC equal to 45 minus 30 equal to 15 millimeter. In case, go back and enter. 15 millimeter. Remember, calculated value. If not clear, better drop the subject now only. Start vertically. This I will not write on the board. We want this distance. See, in the question given, BC is 22, B to C is 22, B to F is 12. This is 22, this is 12. From 22, subtract 12, you will get 12 millimeter. I will round off. Means calculated. Sometime in the class I will tell to students, if you are not getting clearly, leave 10-page gap. Some will be laughing, 10-page gap for one line. Okay, that is for fun only. Okay, now get it. Now your tan theta equal to 12 by 15. Why? I can't answer. Theta, therefore, your theta equal to 12 by 15. Shift tan inverse answer. 38.660 degrees. 38.6 actually 6.5, it came 30. See, I am very careful. 38.6598 is 660 degrees. Okay, if you want 660, third decimal, 0 degrees. Go back and enter. Enter here. Equal to calculated value 38.660 degrees over. Now, see, this I should not explain. This will be equal to the point E, because I considered E, one right side component, one down component. Right side component, 100 cos 38.660 equal to downward component, 100 sin 38.660. Calculate. For I again told, if any calculation mistake is there, don't blame me. Sometimes it happens. See, 78.087. I will tell you, here small question, sometime I may have calculation mistake. But if I am solving a statically indeterminate structure, calculation mistake will not come, because if huge question, some questions you require more than 2 hours. If there is a calculation mistake, I can make out immediately. Why you don't bother? Because that grip on indeterminate structures. Actually, my most favorite is indeterminate structure. I like indeterminate structure solution class much enjoyable than determinate, because determinate structure not much. People tell sir so much is there. Yes, indeterminate I can control the class like anything. Okay, leave it. Lot of time is there. It is in structure analysis into sign. So wait for structural analysis for 62.470. 62.470 Newton. Okay. Now do one thing. You enter these two components either at E or at F. Anywhere you can enter. So see, I make here. I can enter at E if I want E, or I can enter at F also. You write here. Any point will do. But one thing important, you should not enter horizontal component here and vertical component here. That is nonsense. Make a note. Both the components should be entered either at E or at F. It will not have any effect on the answer unless deformation is considered. That is strength of materials later. But you cannot enter 78 here and 62 here. Someone asked, can I do it? No, that you cannot do. Both these components, right, I will enter at E. Therefore, at E, it is here, E point, 78.087 Newton, vertically down of 62 point, correct answer. Angle how much? Angle is 38. That's correct, 62.470. What I am checking? Because when angle is less than 45 degrees, then vertical will be lesser, horizontal is more. Okay, all over. This also over. Now, see, over. Now, lastly, see now. Everything over. Thoroughly practice and get a solid grip. See, I told from beginning, you go study all my classes, understand each and everything I tell. Today I got a comment. He told, sir, I am watching your class at 1.5 speed. Why? Maybe he understands better. I am talking quite slowly in the class. Purpose is even the weakest person should understand. Those who think they know much more. Okay, if at all you think that way, increase the speed. Don't go to 2 like that. Say 1.25. 1.25 the YouTube is there or not there, I don't know. See, 1.5. But then what will happen? If I tell here, consider a force of 10 Newton. Consider a force of 10 Newton. It will tell that way. Okay. But if you don't go for 2, consider for 10 Newton. It will come that way then. So therefore, adjust the speed. If you feel you want to save the time, you can increase the speed. If difficulty is there, come back once again. But don't watch at 0.25. Consider a force of 10 Newton. Don't do that way. Okay. No. Right here. Lastly, consider over now, class over, 60 Newton force. At which point, I forgot last time, at G. Okay. Here see, distance I am not marking here, not required. If you want, you can mark distance also. How much, tell me? See, this not who wants distance, because first of all, the point G, where acting not given. It is somewhere here. It is not given, G point, where? Not required. Why? Our question stops here. Okay, now G. Make a note. Make a note here. It is given that, question given, 60 Newton force. See, if you see x-axis axis here, this is x-axis axis. It is given 130 degree is given. Now write a note here. You should write a statement. Never use that 130. Danger. If you consider the angle 130 degrees, which is more than 90, you are very likely to make the mistake. What mistake will come? I will tell you. See, when I explain law of parallel forces, I told the mistake. So wait for some time. You cannot accept everything in one class. I will tell the mistake, what mistake is there. Till that time you think. Okay, therefore, make a note here. Never consider that angle. In the class he told, consider the angle nearest XX. This angle required. Right there. Statement you are right. In the class I am not writing. Only notes I will write all these things. Now therefore, what is the point here? This point is G. So through the point G, very important, XX here, 60 Newton, never consider this angle. If it is 130 degrees, this angle is 50 degrees. Why means, sorry, no explanation, because I am weak in mathematics, okay, I will tell that way. Some students, rarely they will ask, sir, please explain. No, sorry, not explaining. Equal to, see here, vertically up, horizontally left. I will tell the reason, don't worry. Every point I tell, there will be reason. I will not talk anything without knowing the answer, remember. Okay, now it has got to the point G, one vertical component up, horizontally left. This is 60 into cos 50 equal to 60 into sin 50 equal to over. 60 into cos 50. I told you, in the light sometimes numbers are not clearly visible. If any calculation mistake is there, just ignore it, correct it. Principal mistake is there, comment. You comment, you don't know anything. Okay. That is for me, you comment. This person does not know subject and is teaching. Okay, into sin 50. Sin 50. 45.962. 45.962. 962 or 3, see? 963. I am very careful. 963 Newton. Okay, over. Therefore, lastly, through the point G, see here, there is a left side force of G. Go that side. I tell G, you go that side. Okay, G. How much? 38.567 Newton, and a vertically upward force. Space is not there. Available space 45.963 Newton. Okay, right. Now right here. This is a final sketch where all resolved components are neatly entered at the point of application, so that if you want to find the resultant, this is the sketch you have to refer. See, you take moment about any point. For taking moment, or here you can't take moment. See, if you look at the sketch, how you take moment. Now you can take moment very easily. See, this way you can very easily take moment. This all will come one by one. Okay, today's class over. Next class will be resolution in two mutually perpendicular directions, but when they are not horizontal vertical, both are inclined. But one important, inclined no doubt. See, suppose there's an inclined plane is there. One along the plane, other perpendicular to the plane. They are perpendicular to each other. That perpendicular is very important. Okay, thank you. We'll meet in the next class. Very thoroughly and go through the class. Now, I have to tell, welcome back. If you already came up to here, you can make out, I closed the class and told bye for you, meet you in the next class. I actually uploaded in the YouTube, processing was over, it was ready for publishing. Then I did not make it public. I just came back here to clean the board. At that time, suddenly to the mind, it came. Just check the answer. This direction solve this way. Yes, correct. I ticked it correct. See? Correct. 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 Everything correct. Suddenly I saw, oh, 90 Newton was pending. It was pending. Nothing to worry. I can remove the 90. But then I decided to add to that one. So therefore I'm continuing now. Forgotten. Lastly, if you want to write further lastly, consider 90 Newton force. Something I told in the class you have to write. See, 90 Newton force is given perpendicular to 100 Newton. So unless you know the angle for 100 Newton, you cannot get this angle. Therefore, I told earlier, first to consider 100, I finished, then forgot 90 and came here. Now 100 is already over, come to 90. See, this I remove, this is not required. Okay. Separate right here. See. First, 90 Newton. We want angle with the nearest x-axis. This angle we want, theta. Note, this theta is theta for 90. Even for, see, for this also we wrote theta. That is theta for 100. This is our theta for 90. Now, to get theta, note, this is theta for 90. To get this theta, see, 1 minute now, I will tell what happened. One small mistake happened. Not a big mistake, but some will laugh. Sir has lost control in mathematics. See, theta. Remember, 90 Newton is perpendicular to this force. So write it here. 90 is here. This is 90 Newton. This is our x-axis. This theta we want. Then 100 Newton was this way. 100 Newton. For this, we already got the angle as, I will tell what is the angle we got. 12 by 15. Shift tan inverse answer. 38.66 degrees. 38.66 degrees. Now, remember, there is one correction here. I will tell you. One correction you make. You make one correction. Okay, leave it. I will tell you what is the correction. This is perpendicular. So, this theta equal to this is perpendicular. This is, see, this is already we got when we considered 100 Newton. 1 minute now, I will come to it now. Therefore, this theta, see, this theta equal to 180 minus 38.66, also minus 90. 180 minus 38.66 minus 90 is 51.34 degrees. 34 degrees, right? Go back and enter. Enter. Here's how much I got? 51.34 degrees. Okay, now see here. 90 cos 51.34. See arrow mark if you want. Oh no, see it is reversed. See, good thing happened. See, 90 is this way. It is other force. See, actually it was 100 Newton force. Okay, okay. No problem. See, good thing. See, sometimes it happens. I saw 100 Newton force. I will correct it, no problem. What is there? See, now one component this way, one component this way. Therefore, this will be equal to the point E, one left component of 90 cos, how much? 51.34 equal to one vertical down of 90 sin 51.34. Calculate. Over. Closing part. 90 into cos 51.34 is 56.22. 56.22. 90 into cos of 51.34. 56.223. 223 Newton. Vertical is 90 into sine of 51.34. 70.278. 70.278. Okay, now enter the force there. Forgotten. See, at the point, same point here, one downward force, one left force. There is already one downward force here. So if I write over here, it will be confusion. So I will put here. See, how much? 70.278 Newton and one left force. Space problem is there. See, this is 39.696. This is 39.696 Newton. This is 56.223 Newton. Over. Now correct. So I added this much extra recording. Now I will upload this one. Now one big mistake I made. Remember, I told already in the class, calculation mistake, spelling mistake, or rarely grammar mistake possible. Technical mistake not possible. See, I will tell you what is the mistake. When I see, you make a note here. Where should I write? Okay, I write here only. See, before that, one more thing. See, when this force is given perpendicular to this one, I don't have to do all this because there's a rule is there. If this line makes 38.66 degrees with horizontal, it is a perpendicular will make 90 minus that angle with horizontal. Directly you can write also if you got capacity. Okay, now I will write here. Sorry, here. One very important, make a note. Red color I will write. Not a big mistake. Note and correct. Correct. When I considered, see, I am not ashamed of this mistake. If it is a technical mistake, I will feel ashamed. Suppose I published a video, tomorrow I have to come, published a class, tomorrow I have to come and tell, see, last time something happened, sorry, it never happened earlier, will not happen in future. When I consider 100 Newton force, I put a triangle to get that theta, for it. Theta for it, what I did is, see, point E is here, point C is here, point F is here, this way. This is the theta. See, this theta we want. That time I told this length equal to, see here, this is this length I want. This is 45. Here to here is 30. So it is 15. 15. How I got? 45 minus 30. Correct. Then I told in the class to get this length. See, to get this length. How to get this length? I told B to C is 22. Then I told B to F is 12. So C to F is 22 minus 12. When I told the answer, in the mind, I thought this is 10. I don't know why it happened. Not that 22 minus 12 is 10, I can make out. It is not 12. That much I am not weak in mathematics. See, I told this is 22, this is 12. So this will be 22 minus 12. Then when I told the answer, I forgot this one. I thought it is 10. 22 minus 10, I told 12. So it is wrong. So earlier I told 22 minus 12 equal to, but by wrong thinking, I told 10. Now what to do is, actually I told 12. Now, then this angle will change. Instead of that way, what to do is, therefore, do one thing, in the question, correction. But this I can do it. Examination you can't do it. So correction is, that is, see right here, the BF given 12, this 12, change it to 10. Change it to 10. Okay. Therefore, now this will be equal to 22 minus 10. See, corrected value 10 equal to 12. Therefore, tan theta, not this one, earlier tan theta equal to 12 by 15. Then you will get that angle. How much? 12 by 15. Shift tan inverse answer. 38.66 degrees. Okay. Earlier also I took, right, this is the angle we considered to get these two components. Mistake was 22 minus 12. I told correctly, I told actually, if you are not able to understand high school level, but what happened is I told 22 minus 12. Then when I was the answer, I don't see there. See, I don't have good by-hearting capacity or remembering capacity. I suddenly thought it is 10. I don't know why it thought. So 22 minus 10 is 12. 22 minus 12, 10, I know it. So therefore, this 22, 12 mm given, you change it 10 mm, then if you change it 10 mm, your theta will be correct. This also will be correct. You know, such things should happen. See, human nature. I told calculation mistake, spelling mistake, occasionally, rarely grammar. Usually I don't make grammar mistake, but no technical mistake. That is guaranteed. Okay. Thank you. We'll meet in the next class. Now I have to add this one to the previous recording and once again upload. Okay. Thank you.